RB-based Research Academy welcomes to you in the video number 15. In this one, I'm going to discuss about the structural part of our SmartPLS model. Dear friends, you're looking here one image. There are the two parts. One is a measurement model and it is a structural model. In the measurement model, further we have the two reflective and formative. And on these two I have the separate videos are available. I have provided there is a link of all these videos at the end of below this video. And in this video, I'm going to discuss about the structural part of that one. So how to assess the structural part? There are the 6 steps are there. You are looking right now in this video number 15, part 1. I have discussed the first three steps, and in the part 2 of this video, I have discussed the remaining 3 steps. Dear friends, my name is Dr. Raimel Sumro, and I'm from Shabati University, Pakistan. This is my certificate, which has been awarded to me from the SmartPLS Academy, Germany. And from this academy, I have covered these 9 models. Okay. Now I'm going to start about the structural model. So first of all, I think it's better to understand about the structural model. Although it is a practical video, but it is my habit to bring some of the theoretical stuff as you can be sufficiently able to understand what is being on. So now you're looking here. The structural model involves examining the model predictive capabilities and the relationship between the constraints. So 2 things it is going to do. One is assess that up to what level this model can predict. That means its predictive abilities are being assessed by the structural model. As that means it is also assessing the relationship among the constructs. In the previous video, in the measurement model, that means that we were checking the relationship among the items of the construct, and in this one we are checking the relationship among the constructs. So that is the job of the structural model. Okay, and furthermore, I want to discuss about that. So quality is a big issue. Even it may be you are working on the reflective or on the formative measurement model, or even if you are working on the structural model, again the collinearity is a big issue. So that's why most of the time we are talking about the collinearity. How to check the collinearity? To check collinearity, we have the 2 tools. One is a tolerance and another the VIF. In the last video, I also talked about the VIF. So the minimum value, if the value of any construct is more than 0.20, it means there is no any collinearity. If its VIF is less than 3 or less than 5, then again there is no any problem of the collinearity. Okay, and then you are looking here that if the critical level of the collinearity is indicated by the tolerance or the VIF guidelines, it means furthermore, if there is any collinearity in your construct. Now how to solve this problem with regard to the construct? So now one should consider eliminating the construct, outrightly eliminate that construct, or the merging predictors into the single construct, or you can take out the predictor from the both constructs and then merge both constructs in one construct. Or the third solution is to create the high order constructs. So to treat the quality problem. So these are the 3 in fact solutions are there when you want to solve the quality problem. Now how to check the quality problem? That's very easy. So I'm going to open a very famous example from the book, which image you're looking here. Extinction model. Double click it. Okay, now the model has been emerged on our interface. So now just quickly we are going to calculate. So as all our latent variables, they are reflective. That's why we prefer to choose PLS algorithm instead of the consistent PLS algorithm. Okay, so these are the good. Okay, and then start calculations. So it's very quick to calculate all these things, and the results have been provided to us. Okay. Now the one method is to check through the quality criteria. In the quality criteria, quality statistic or VIF are available. So in this one, I think there is no any violation. So now completely all the indicators of all your constructs are well below than our benchmark. So there are the three benchmarks are there. If you are highly conservative, then the 3 is okay. If the value of any one is more than the 3, then you may consider to drop that one, to drop that item, to drop that whole construct. If you are so conservative, if you become somewhat liberal, then the 5 is okay. And if you become the highly liberal, then the 10 is okay. So I prefer always 5 instead of the 3 or 10. We have checked. Now we are going to discuss about the structural path coefficients. So before taking some of the theoretical concepts which I want to provide you, that is the after running SmartPLS algorithm, as we have run right now the algorithm, the estimates are obtained for structural model relationship path coefficient, which represent the hypothesized relationship among the constructs. Okay, so now we are developing a one hypothesis, and according to that hypothesis, you are creating a one path between the independent variable and the dependent variable. So these arrows, these lines are your path, are your hypotheses are there. Okay, and the next one is the path coefficient have standardized values approximately from between the -1 and +1. Values can be smaller or larger, but usually will fall within the between these bounds. So now bounds are -1 and +1. So now the value of these path may be anyone, but these will remain within the +1 and the -1. Higher the value, better the results, better the effect is there. Now, for example, this is the one of the path. These are all are the paths. So now we want to check the impact of the performance on COMP. We want to check the impact of quality on this one. So the biggest path among all the path is here, probably 0.430. Okay, and another one is the CUSA. It has impact of the 0.505. So these are quite sufficient impact are there. So all these are the path are there. So now see all the range is between the +1 and -1. So now 0.430, it means it has a positive impact, and the value of this impact is a 43% of the quality on the COMP. Okay, so now for example, if there was a one sign, negative sign before this one, then we pronounce it that there is a negative relationship between the quality and the COMP, and its value is a 34%, 43% is there now. Okay, now we have got some of the paths which are there. Okay, and then the problem is that we do not know either this path is significant or not. So now significance we can know with the help of the PRT value, but we do not know because it's a non-parametric software is there, so that's why it does not provide you. So far, in order to get all these ones, this what you should do. We should start to apply the bootstrapping. For example, you're looking here. The bootstrapping standard error enable computing the empirical T and values and the P values of the structural path coefficients. So now, through the bootstrapping, we get a standard error in the shape of the P value or the T value, and based on this one, we decide either that this is a significant relationship is or not. Okay, and then another thing is about the significance levels are there. There are different significance levels normally we use. And like you are looking here, commonly the critical values for the two-tail. If you are working on a two-tail test, then the 1.65 that is equal to 10%, 1.96 that is equal to 5%, and 2.57 that is equal to the 1%. If you are working on the one-tail test, then 1.28 for the significance level of the 10%, and 1.65 that is equal to the 5%, and the 2.33 that is equal to the 1%. So this one. Okay, now the significance level are different from the in the different areas. So normally, that means if you are working on exploratory research, then if you are selecting the 90% as a confidence interval, that's good thing. And if you're working on this purely on the experiments, then it is better to focus on the 99% confidence interval, and rest of means you can in the normal you can choose the 5% and 95% confidence interval. Normally we are following the 5% confidence interval. Okay, and one more thing is that is a path effect, a path analysis, but we want to check some more thing in that one. These are the path coefficients. You are looking here the path coefficient between the attraction and the company and the attraction with the likability, and then the COSR between the COMP, and then the CSOR between the likability. So these are some of the path coefficients, and these are our indirect path coefficient, where we want to check the impact of attrition on CUSL through the CUSA, and where we want to check the impact of the quality on the CUSL through the CUSA. So all these are the paths, indirect paths are there. So now either these are significant or not. So this will be decided with the help of the boosting. By the way, my video number 14 part 2, in this one I have discussed about the how to apply the bootstrapping technique on the on SmartPLS, in the SmartPLS. Okay, another is a total effect. So that is total effect. Now total effect we call is a the addition, the sum of the indirect and direct effect. We call this when we add the direct indirect with each other, it becomes a total effect. So these are results of the total effects. So by the way, in the final results, we have so far discussed about the path coefficient, indirect, total effect, outer loading, outer weights, and latent variable. Okay, so here two tools we have discussed right now, and a last tool. So last one is about the coefficient of determination R-square. You are looking here the most commonly measured to evaluate the structural model of is the coefficient of determination R-square. And then we ultimately we call there's an explained variance of the independent variable in the on the dependent variable. For example, you're looking here the one definition, the coefficient represent like the coefficient of determination R-square represent the exogenous latent variables combined effect. Exogenous latent variable means independent latent variables combined effect on the endogenous latent variable. Endogenous means the independent variable. There's one definition of the R-square. Another one is that's the coefficient represent the amount of variance in the endogenous construct explained by the all exogenous variable which are linked with each other. So that is our R-square. Okay, now what should be the value of the R-square? So that is also some of the thing which we should consider. So what should be the minimum level of the R-square? You're looking here, it is scholarly research that focused on the marketing issues or issues of the management. The R-square values 0.75, 0.50, and 0.25 for endogenous latent variables can, as a rule of thumb, be respectively described as a substantial, moderate, and or weak. So a few things are there. That the R-square is a 0.75, that's a substantial. Okay, if the R-square that is from 0.5 to 0.75, that's a moderate, and a 0.25 to 0.50, that is a, I think that's a okay, that's moderate, and less than the 0.5 there is a B. So this is one type of the criteria we should keep in our mind. So let's check our R-square. So to check out R-square, we have to come into the quality criteria. R-square, if you click it, then you will find this R-square. Alternatively, you can also find R-square from here. From here, you can also find R-square. Okay, AVE. Here is R-square. If you click it, you will find that R-square. Now, R-square you will find only on the dependent variable, not on the independent variable. So here there are the 4 independent variables are there in this model, and rest are our 4 are our dependent variables. So our these. So the values of R-square you are finding on the dependent variable. Let's see the how up to what level they are good. Either they are within the range or not. So in this regard, the R square 0.631. That's a substantial contribution, I think so. Because now this one, this independent variable, this independent variable, this and the last one here. So these are the 4 independent variable are there. Like this is another dependent variable. Okay, so these 4 dependent variables are there which are sufficiently contributing. So these are 4 independent variables which are sufficiently contributing in the R square of the COMP, and its value is 0.63. That means that in other alternative we can say 63% explained is there. So 63% that is explained. Unexplained, that means that when you deduct 0.63 from the one, the rest of the amount is your unexplained. So here, if you compare all these ones, that the value of this one is less than the all among the less than the all the R square. Now, reason is that means that it is only 2 independent variable. Okay, so now there, so that's why that's probably the main reason. That's why its R square is lesser than all the other R squares which are available here. Okay. One more reason is that if you they include more like the independent variable, then you see that the R square will be increased. So that means the value of the R square also depends on the number of the indicators. Higher the number of the indicators, probably higher the value of R square. Lower the number of indicators, lower the value of R square. And then you're looking here R square, that is also independent variable, that's also independent variable, that's also independent variable. But even though R square are there, the problem with this one that these 3 are, although these are the independent, but at the same time they are also playing a role of a dependent variable. So they have the dual responsibility to fulfill. That's why they means at one time they are independent, at another time they are independent variable. So dear friends, practical work which we have covered. So now I want to show some of the research papers. That is the how they have reported these 3 things. So let's move towards our research papers. So dear friends, these are our research. This is the first research paper. So directly we are coming on the model. This is our model, proposed model, and this is the model which the way of applying the already studied techniques. So in this one, the first thing is that is about the path. That is about direct path. That's a path analysis. That means where we want to check the impact of educational support for developing entrepreneurship on the entrepreneurial self-replication. So that these are the paths are there. Okay, and this is the path, and then this is the direct path. This is also direct path. This is also direct, and this is the indirect path. That means where we want to check the impact of the conceptual support on the green entrepreneurship intention with the help of the through the entrepreneurial self-efficacy. So this one is in our indirect. So when you combine direct indirect with each other, it will become the total effect. Okay, and these are the contribution of the each indicator. Okay, so these are the good contribution of every indicators are there, and this is our R square. This is also our R square. Okay, and then we are opening our another research paper. Quickly, we are going on our model. This is our proposed model, and here we have some of the results of this model. Okay, so now first of all, again the same thing, path, direct path results. Now here is a negative relationship. Now the biggest impact is the techno stress, that means the stress of a technology while on your exhaustion. So if you continually work on the exhaustion, definitely it has the technology, the negative, that means we have impact. So now we will get exhaust from the working on this one. So now if we want to check the impact of the techno stress on the academic performance through the exhaustion. So now that's why this is our indirect effect and this is our direct effect. Okay, so now there's negative relationship, and all these there is a positive relationship. Negative relationship in this sense that the higher the exhaustion, lower the academic performance, lower the exhaustion, higher the academic performance. Okay, so these are the path, and this is our R square values are there. Okay, And then these are our indicators, the contribution of every indicator in the model. Okay, so dear friends, I think the results have been clear in your mind right now. We are going back towards our model. Dear friends, now we have checked, applied all these three tools on this data. I hope this video has become again highly useful for you, especially some of the concepts which I discussed here and the practical of which I have done here. I hope. So at the end of this lecture, I request you please take care of yourself and take care of this channel by watching the videos, by referring to your friends, by leaving some comments and other good things you can do with this one. Okay, thank you very much for watching this video.